Okay, section 4.5, we want to be able to graph sines and cosine functions. We're going to walk through a number of problems here doing this. We're going to end up using some transformations or some shifts to also easily manipulate or graph sines and cosine functions. And we're going to pay attention to the fact that there's a periodic behavior to these graphs. They're pretty much the same function over and over again. There's a lot of repetition here that we're going to see. So we're going to start first by graphing a sine function, but I'm going to take my time and I'm going to plot some points. Now, keep in mind this is a function that we could, if we needed to, we could, and we'll do this just for this graph, plot some points. Normally we would plot x and y's. Now keep in mind that x is really your theta, right? Y equals sine theta. And we're calling it x when we graph because we're using the x and y coordinate plane, so we're using x's and y's. It may get confusing at times, but if you keep the reason that we're plotting this in mind, then we're in good shape. So we're going to start with theta being 0. We're going to work with degrees just so that we're not too confused. We'll go back to radians for cosines, but the plot is going to be the same or very similar. So 30 degrees, 45 degrees, 60 degrees, 90 degrees, 135, 180, 225, 270. From 270 we go to 315 and 360. And I notice I skipped a bunch of little ones in the middle. Once we get to here, we're going to start seeing a repetitive nature in this. So notice that when I plug in for a sine function, when I plug in 0, and you guys all should be using a calculator for this. I want you to go ahead and plug this into the calculator and see what you get. Now make sure that you're in degrees. That'll make a difference. So when you plug in 0, you get 0. When you plug in sine of 30, and again, take a second, plug it in, sine of 30 degrees. Make sure that you're in degrees. And notice that you get a 0.5 because the sine of 30 degrees is 1/2. These are things that we know, right? Okay, cosine or sine of 45 degrees we know is root 2 over 2. Well, root 2 over 2 is approximately 0.71 if you plug this in the calculator. Sine of 60 degrees is going to be root 3 over 2, or 0.87. Sine of 90 degrees is 1. Okay, and from here, things are going to start being repetitive. Now let's go ahead and finish plugging these in quickly. At sine of 135, you're also going to get root 2 over 2, or 0.71. At 180 degrees, you're going to end up with 0. At 225, negative 0.71. 270 is going to be negative 1. 315 is going to be negative 0.71. And 360 is going to end up back at 0. So you end up with again, a repetitive nature. Notice that some of this is positive, some of this is negative. Now, when we're graphing this, one of the things we want to pay attention to is that you have a y-axis. Highest point is going to be 1, lowest point is going to be -1. On the x-axis, you've got your angles. So my period here literally is 360 degrees. So I'm going to put 360 degrees here. Half that is 180. Half that is 90. Half that is, or I'm sorry, if I count by 90s, 90, 180, 270 goes right here. Now, in order to graph that first one, notice that I have between 0 and 90, I have three angles. Now, normally I don't write these, and normally you guys are going to do this in radian measure. If you are spatially challenged, please use a ruler. If you're close enough, if you can get it close enough, you can sort of space it out. This is going to be 45 right in the middle. This is 30 degrees, and this is 60 degrees. Now, in reality, you guys, these are not in the middle right here. So I'm gonna take that. I'm gonna delete that just so that you can see that yes, 45 is in the middle, but 30 and 60 are going to be closer to 45. They split this up into 3 equal sections here, right there. So again, just as you're doing this, you can see this. Now, normally you're not going to have to go through this. I want you to see the graph, though. All right, so here we go. We're going to plot 0, 0. We're going to plot at 30 degrees is halfway up, so that's got to be right about there. At 45 degrees, it's a little higher. At 60 degrees, it's even higher still, but not quite as high. And then at 90 degrees, we hit a maximum point at 1. Now notice that this graph is a curve. Okay, that curve ends up repeating. Now notice that from here, I didn't do all the 30 and 60 degree multiple angles. So I'm gonna go ahead and plot some points. I know right here in the middle, I'm going to be at 0.71. I'm going to come down to 0. I'm going to come down here to -0.71 to -1, back to -0.71, and then back to 0. If I follow that process, I end up with this curve right here. And this is a repetitive curve. In reality, this will continue this direction, this will continue this direction, and we've got our sine wave. For the cosine function, again, we could plot points. I'm not going to. I'm going to trust that if you are confused, you're going to take some time to do that. Again, my period here, we're going to figure out, as we saw, one full rotation in the sine wave turned out to be 360 degrees. Same thing is going to be true for the cosine function. Instead of 360, we're going to write 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2. This is 1 pi over 2. This is 2 pi over 2. This is 3 pi over 2. This is 4 pi over 2. So right here, this should be a 3 pi over 2. So literally once you get the first ones in there, that third one is just counting. If you need to, -pi over 2, and we'll show that. The maximum height is still 1. The minimum height is -1. So you need to set up your graph and label the x and y axis. If those are not labeled, you're going to lose points on a test. All right, from here, again, you can plug this into a calculator, but the cosine function starts when x is 0, y is 1. And we know this from our trig functions. When x is pi over 2, y is 0. When x is pi, y is negative 1. When x is 3 pi over 2, it's 0. And then we come back at 2 pi, x is 2 pi, y is 1. And again, notice that the shape of this, because this is not a straight line. Remember, this is a curve. Looks something like this, and it's repetitive. Yes, this would continue this way. Yes, this would continue this way. Okay? What I've graphed originally is one period, or one full cycle of the cosine function. Okay, so Blitzer gets into the graphs fairly quickly. If you graph this with your graphing calculator, you'll see that these things continue in both directions, and it's repetitive. Again, sine wave, one period is 2 pi, or one full cycle. And that full cycle, if you wanted to, you can shift it. You can shift it all over this way, and here's your cycle. Or you could shift it back this way, and here's your cycle. So again, you can find that cycle just about anywhere on the graph. Notice too that the sine wave, if I cut it off here, looks like I've got a cosine function in there. And that's because you do. It's a cosine function with a shift. And we'll investigate that and see that as we go. Blitzer gives you a good description of what we're doing. We know that our domain is between 0 or between negative infinity and infinity. Our range is between negative 1 and 1. It doesn't go any higher than that unless the amplitude changes. Our period is 2 pi, again, unless we have some multiplication, some higher frequency. The function is an odd function. If I plug in negative x, I get exactly negative sine of x, which means instead of going up on our function, we go down on our graph. So it's an odd function. Something to pay attention to. There's a lot of information here that you guys are going to have to absorb. Again, Blitzer gives you a step-by-step process. I'm going to let you go through and look that up and read that if you need it. Stop the video, do what you got to do.